Hello and welcome to a video on inscribed angles and circles. I want to thank you for coming around for this. Alright, we're starting off great. So this is an all basically definitions and theorems video again, and you'll use those definitions and theorems to work through your problems. So first we're going to start with these three definitions. First, we have the definition of what an inscribed angle is. I figured that would be the best thing to start with, since that's what the video is about. So an inscribed angle is an angle whose vertex is on a circle and whose sides contain chords of the circle. An intercepted arc is an arc that lies between two lines, rays, or segments, and a subtend is the quarter arc whose endpoints lie on the sides of an inscribed angle. So let's put all these words into an actual picture. So here's a picture of our circle. In red we have the inscribed angle. You can see how it's two chords that have the same point here, and then they meet on another edge of the circle. So that's what an inscribed angle is. And then in blue we have the intercepted arc, which is the arc of the circle here. And we also have this chord here, which touches the two ends of our inscribed angle. And both the intercepted arc and that chord can be called a subtend. So let's get into some theorems that use the inscribed angles. So our first is the measure of an inscribed angle theorem. It states that the measure of an inscribed angle is half the measure of its intercepted arc. So this will help us solve problems whenever we're trying to find the inscribed angle or the intercepted arc. So if we know the measure of angle BAC, so if we know what this angle right here is, we can figure out the measure of this arc by either by multiplying it by 2, or if we know the arc, we can cut that arc in half to find the angle, which is actually what this theorem talks about. But we can go backwards with this as well. So if you know the arc, you cut it in half to find the angle. If you know the angle, you can multiply it by 2 to figure out the arc. Now let's talk about inscribed angles of a circle theorem. So this is talking about if we have two inscribed angles. So if two inscribed angles of a circle intercept the same arc, so they have the same intercepted arc, then the angles are congruent. So if we've got two inscribed angles, like we have down here, we have the we have the green inscribed angle and the yellow inscribed angle, and they're both intercepting this same arc in blue. When that happens, we can say that those two angles are congruent. So we can say that angle CAB, which is the green one, and then angle BDC, which is our yellow one, we can say those are congruent according to this theorem. Okay, now we're going to shift and talk about some polygons. So we have two definitions here. We have an inscribed polygon, which is a polygon with all vertices, all vertices on the edge of the circle. And then the circumscribed circle is the circle that contains the inscribed polygon. So inscribed polygon, it's inside the circle, and the circumscribed circle is a circle that contains that polygon. So we have a couple theorems with this. First theorem is a long one. It's the inscribed right triangle theorem, but it is a very useful theorem when we're dealing with circles and triangles and trying to measure using this. So if you have a right triangle that's inscribed in a circle, then the hypotenuse is the diameter. So if there's a right triangle inscribed in a circle and you know that, if it tells you that, you automatically know hypotenuse is the diameter. Or If you're just looking at a triangle that's inscribed inside a circle and you notice that one of those sides is the diameter, then you know that it is a right triangle and the diameter is the hypotenuse. So it kind of works back and forth with each other. So if we see here in this circle, if segment AC is the diameter of our inscribed triangle, ABC is a right triangle. And that right angle is always the angle opposite of the hypotenuse. So the angle that's opposite of your diameter will be your right angle in that triangle. And our last theorem is the inscribed quadrilateral theorem. So it says a quadrilateral can be inscribed in a circle if and only if its opposite angles are supplementary. So we need those opposite angles to add up to 180. So if in this picture we have, sorry that was a yawn, this is my first video I'm remaking for the summer, so it's trying to get the body back used to it, yawning. So the measure of angle A plus the measure of angle C equals 180 degrees. Then the measure of angle B plus the measure of angle D equals 180. We can say that this is an inscribed quadrilateral. It works. We can also say that the measure of angle A plus the measure of angle C equals the measure of angle B plus the measure of angle D, which that could help us solve some equations. If we know what A, B, and C are and we're trying to find D, we could use that. And there's just all sorts of different things that we can do with that. So here is your video on that. Go ahead and get working on some practice problems.